Hello friends, I am Dr. Karpagam Chinnamman from Chikana Government Arts College, Tirupur in Tamil Nadu. Today we are going to deal with the different stages of dyeing textiles. Dyeing is a process of beautifying textile products by applying colors. Colors can be applied at different stages of textile production process. Quality woolen goods, for example, are frequently dyed in the form of loose fibers, but top dyeing or cheese dyeing is favored in treating worsteds. Manufacturers prefer piece dyeing, which allows stocking of white goods, thereby reducing the risk of being overstocked with cloth dyed in colors that have not been ordered. In this session, we would understand the various methods of dyeing fiber, yarn and fabric, get an insight into the advantages and applicability of each method, learn about the machinery involved in dyeing. Textiles may be dyed at any phase of manufacturing of textile product. It may be colored as fiber, as yarn, as fabric, or a finished product including garments and apparel. The range of methods include stock dyeing, top dyeing, yarn dyeing, piece dyeing, solution dyeing and garment dyeing. Fiber dyeing. The process of dyeing fibers before they are spun into yarns are called fiber dyeing. Fiber dyeing includes stock, top and toe dyeing. Stock dyeing refers to dyeing raw fibers or staple fibers, also called stock, before being spun into yarns. There are two methods in the older and common method. The packed fibers are removed from the bale and put in large vessels and dye is circulated through the fibers at high temperatures. In the newer method, bale dyeing, the bale covering is split on all sides and placed in a specially designed machine, and the dye liquor is forced through the bale of fiber. This method saves time and labor cost and is suitable for wool and man-made fibers. Though the dye liquor is pumped in large quantities through the bale, it may not dye the entire bale and some portions may be left without dyeing. However, in the next process of blending and spinning, the undyed fibers are mixed thoroughly with the dyed fiber that an overall even color is obtained. Top is nothing but the combed wool sliver. Top dyeing is a process of dyeing worsted wool fibers after it has been combed or straightened and removed the short fibers. This method is favored as the dye is not wasted on the short fibers that are removed during the combing process. Top is wound on perforated spools and the dye solution is circulated through it. This method results in very even dyeing. The filament fibers, before they are cut into short staple fibers, are known as toe. The dyeing at this stage is called toe dyeing. The advantages of fiber dyeing are: uniform dyeing is obtained as individual fibers get dyed without any resistance. The dye penetrates well into the fiber and so the problem of crocking is avoided. By mixing of the dyed and undyed fibers before spinning, it is possible to get unique effects. The disadvantages are: fiber dyeing is relatively costlier than yarn, fabric and product dyeing. If not carefully handled, there is possibility of the loose fibers getting entangled. Dyed fibers loses its flexibility and so does not spin as readily as undyed fibers. High percentage of fiber loss from dyeing and later yarn spinning, resulting in loss of color also. Dyeing long before season begins carries risk of fashion changing. Woolens are usually fiber dyed. Yarns with two or more colors are normally fiber dyed. For example, dyed black wool fiber might be blended and spun with undyed white wool fiber to produce soft heather-like shade of grey yarn. The next is solution dyeing. Solution dyeing also is called as spun dyeing. It's a process for dyeing synthetic fibers. Pigments or insoluble dye is added to the spinning solution before it is extruded through the spinnerets for producing synthetic filaments. This results in filaments that are fully impregnated with pigment coming out of the spinnerets in a one-step process. Advantages of solution dyeing are: the color pigments become a part of fiber, and so solution dyed materials are bright and have excellent color fastness to all agents. Solution dyed yarn is resistant to UV fading. The coloring is uniform in solution dyed yarns, and there is no variation from one lot to the other. As no water is involved in the process, it is environmentally friendly. Disadvantages of solution dyeing are: it is practically impossible to solution dye yarn in small lots. The tenacity of solution dyed yarns are slightly lower. The stage of dyeing is more costly because the apparatus has to be cleaned carefully each time the color is changed. Hence, only limited variety of colors are produced. This stage of dyeing is not used for apparel fabrics, as color decisions have to be made very early in the manufacturing. Applicability of solution dyeing: it is mainly used for dyeing fibers which are difficult to dye, and for those fibers used in end products that require excellent color fastness properties. Solution dyeing is recommended for prime colors like black, yellow, green, red and blue. Solution dyed yarns are resistant to UV fading and dye bleeding, so they are suitable for producing polyester and nylon sewing threads. Package dyeing involves a lot of water and energy, cost is also high, so many manufacturers are changing to solution dyed yarns to reduce pollution. Yarn dyeing: the process of dyeing after the fiber has been spun into yarn and before they are woven or knitted into fabrics is referred to as yarn dyeing. In this stage of dyeing, the dye penetrates to the core of the yarn. There are several forms of yarn dyeing: skein dyeing, package dyeing, warp beam and space dyeing. Among the various yarn dyeing methods, package and hang dyeing are the most frequently used methods. Polyester or polyamide yarns are always dyed in package form. Cotton yarns are mostly dyed in package form, and acrylic or wool yarn are dyed in hang form. Skein dyeing: the yarn is wound loosely into hangs or skein or hung over a pole and immersed in a dye bath. The color penetration is excellent in this method, and the yarns retain a softer, loftier feel, but the process is time consuming and expensive. Package dyeing: in package dyeing, yarns are wound on small perforated spool, cone or similar units, and these packages of yarn are stacked on perforated rods in a rack and immersed in a tank and dyed under pressure. The flow of the dye bath can be altered from center to the outside and then from the outside to the center of the package. Package dyed yarns do not retain the softness and loftiness as skein dyed yarns. While package dyeing is suitable for most materials, thick, high twist yarns may not allow for good dye penetration, and materials exposed to outdoor environments experience fading and shade changes. Advantages of package dyeing are: low liquor ratio, less yarn handling, large batches, high temperature dyeing is a possibility, savings in water, effluent and energy, uniform liquor circulation, hence even dyeing. Beam dyeing: in beam dyeing, the yarn is wound on a perforated warp beam and immersed in a tank and dyed applying pressure. It is economical than skein or package dyeing, but it is used only in the manufacture of woven fabrics, because knitted fabrics are mostly produced from the cones of yarn and are not adaptable to beam dyeing. Space dyeing: in this method, the whole yarn is not dyed. It's dyed at intervals along its length. In knit-deknit method, the yarn is first knitted, then dyed and then deknitted. Since the dye does not readily penetrate the areas of the yarn where it crosses itself, alternated dyed and undyed spaces appear. Another method, the OPI space dye applicator technique, produces multicolored space dyed yarns. The yarns are dyed intermittently as they run at very high speeds through spaced dye baths. Advantages of yarn dyeing are: the primary reason for dyeing in the yarn form is to create interesting checks, stripes and plaits with different colored yarns in the weaving process. Yarn dyed fabrics are usually brighter and richer in color. The disadvantages of yarn dyeing are: it's the second most costly dyeing method. As the dyeing is done before season begins, there is risk of fashion changing. When we consider the applicability, this process is suitable when different colored yarns are required in the construction of fabric, example plaits, checks, etc. Piece dyeing. The dyeing of cloth after it has been woven or knitted is known as piece dyeing or fabric dyeing. The various methods used for this type of dyeing includes beck, jig, pad, jet and beam dyeing. Beck dyeing. It's used for dyeing long lengths of fabric continuously. The material is passed in rope form through the dye bath without any tension. This rope of fabric passes over a rail into a reel which immerses into the dye and it draws the fabric up. This process may be repeated until the desired color strength is obtained. Jig dyeing. The fabric in jig dyeing is held on rollers in open width and is passed through a deep dye bath until the desired shade is achieved. This reduces fabric tendency to crack or crease. Pad dyeing. Pad dyeing is carried out with a machine called a dye pad. The fabric in full width is passed through a trough containing dye bath and then it is passed between two heavy rollers which forces the dye into the cloth and squeezes out the excess dye. Then it is passed through a heat chamber to set the dye. Then the fabric is washed, rinsed and dried. Jet dyeing. In the jet dyeing process, fabric is placed in rope form in a heated tube where jets of dye solution are passed through it at high pressure. The fabric too moves along the tube. The solution moves faster than the cloth while coloring it thoroughly. As only very little tension is applied, this method is suitable for dyeing delicate fabrics. High temperature dyeing is also possible on most jet dyeing machines. Beam dyeing. Beam dyeing for piece dyeing is practically identical to beam dyeing used for yarns. Fabric is wound onto perforated cylinder and the dye is forced through the fabric layers. The fabric remains stationary. Beg and jig equipments are the commonly used methods in piece dyeing. The advantages of piece dyeing are: compared to other stages, fabric dyeing is very economical. It is adaptable to both woven and knits. Wastage can be avoided as color decisions is made finally after the fabric is manufactured according to the fashion statement at that particular time. Disadvantages: it's limited to solid colors. In tightly twisted yarns and heavy woven fabric, dye penetration may not be good. Considering the applicability, it's the most suitable method for solid colored fabrics. Next is garment dyeing. When the finished textile products such as apparels and garments are dyed, it's called garment dyeing. It's also called product dyeing. The type of apparel that can be dyed are mostly non-tailored and simpler forms such as sweaters, sweatshirts, t-shirts, hosiery and pantyhose. The effect on sizing, threads, zippers and snaps must be considered. Garment dyeing is carried out by packing a suitable number of garments loosely into a large nylon net bag. A number of these bags are placed in large tubs containing the dye bath and are kept agitated by a motor driven paddle in the dye bath. The machine is called a paddle dyer. The advantages of garment dyeing are: the choice of color is closest to the fashion season, elimination of material waste from prior processing waste, rejection is less, no possibility of shade variation within the garments, small lots of fabric could be produced at lower cost within less time. Compared to other methods, capital investment is less. In some cases, lower liquor ratio in garment dyeing requires lower water, steam and chemical consumption, hence lowers garment dyeing cost. The disadvantages of garment dyeing: it's limited to garments of simple construction. Tailored items such as suits cannot be dyed as garments because the difference in shrinkage of the various parts and linings distort and misshape the article. It's not suitable for garments with lining, zipper, etc., as each part may be dyed differently. It's a labor intensive process and it has poor appearance as well. Applicability: the process is suitable when all components including threads dye the same shade. For example, sheer pantyhose are knitted using tubular knitting machine stitched with thread that dyes to the same shade and then dyed. Product dyeing is best for quick response t-shirts, sweaters and other casual clothing. Activewear, slack, jeans items, pantyhose, shirt, terry items, etc. are dyed using this technique. When we go on to the dyeing machinery, the conventional dyeing machines are constructed on the basic principle of either the movement of material to be dyed in the stationary dye liquor as in jigger, padding mangle or winch, or movement or circulation of dye liquor through a stationary package of material as in cheese dyeing or bean dyeing machine, and in some others both the material and the dye liquor are kept in motion. First, let's look into some of the fiber dyeing machines. Loose stock fiber dyeing machine. A commonly used machine for fiber dyeing is a conical plan with forced circulation. Fibers are packed in a conical vessel B and retained by a lid C, which can be held down with a number of clamps. A flange at the bottom of the container fits into a seating through which the dye liquor is circulated by a centrifugal pump. The fiber mass tends to become compressed in the upper narrow half of the cone, assisting efficient circulation. A gantry and travelling hoist are necessary to lift the container in and out. Yarn dyeing machine. Huzong machine is a traditional apparatus for hang dyeing. It consists essentially of a frame carrying poles A on which the hank D are hung and which are lowered into the rectangular vessel containing the dye liquor. The liquor is circulated by means of an impeller through a perforated false bottom. The false bottom also serves to separate the steam pipe F from the load. The impeller rotates in opposite directions alternatively so that the circulation is either from below the false bottom upward and back into the impeller compartment over the top, or in the reverse way. The volume of flow can be regulated. During dyeing, the direction of the flow must be altered from time to time. When the current is in downward direction, the liquor does not come into sufficiently intimate contact with the portion of the hank upon the pole, and this would lead to higher mark unless the yarn is lifted while the flow is upwards. In practice, the upward direction is used for the greater portion of the dyeing cycle, as liquor is compelled to come into uniform contact with every part. Package dyeing, in that we will see the cheese dyeing machine. Large amount of yarns are dyed in package form. Yarns are often wound in the form of cheese, cones and cobs. These machines consist of an outer vessel for containing the dye liquor, which is positioned with skeleton frame provided with number of perforated tubes in communication with a common central hollow base. The wound packages of yarn are dropped one above the other on these perforated tubes so as to enclose them tightly. Cover of the outer container is then secured. Dye liquor is withdrawn from the outer container and forced up the tubes outwardly through their perforations, and so through the yarn package and back into the outer dye liquor container. The direction of flow of this dye liquor can be reversed automatically from time to time. These dye liquor circulating machines have in recent years been modified to the use of high pressure, high temperature conditions, which is desirable for dyeing synthetic fibers. Yarns normally difficult to absorb dyes. Fabric dyeing machines. The first one is jigger. This machine, also called jig, is most commonly used for dyeing almost all kinds of fabric in full width. The jigger is a simple machine which consists of a V-shaped rough A fitted with the draw rollers along each side of the machine. The cloth to be dyed is wound on one of the rollers called the let-off roller B, from which it is unwound and passed through the dye liquor in the trough with the help of guide roller D and an immersion roller F to the other draw roller on which it is wound. The dye liquor is heated by means of an open-ended steam pipe. The passage of cloth from one draw roller to the other through the dye liquor E is called one end or one turn. The number of ends to be given depends on the depth of shade, absorption capacity of the cloth, type of dye stuff used and the time required for one end. If all the dye required for dyeing is added to the jigger at the beginning, it results in a defect called tailing, that is, continuous decrease in the depth of shade from one end of the batch to the other. This is eliminated by adding only half the amount of dye initially and adding the rest at the end of the first end and before starting the second end. During the dyeing, a rubber roller is kept pressed against the roller on which the cloth is being wound so that the dye solution can penetrate into the fabric. The disadvantages is it is a batch wise process and hence only small lot of cloth can be dyed at a time. During dyeing, the fabric is pulled from one roller to the other, exerting considerable lengthwise tension, which is injurious to delicate fabrics which have low tensile strength. In the case of heavy fabrics like canvas or twills, only surface dyeing of the material takes place because of the difficulties of penetration of dye liquor. The next one is winch dyeing machine. During the dyeing of fabric in a jigger or a padding mangle, the fabric is subjected to considerable amount of tension. This is undesirable in the case of delicate fabrics like viscose rayon, woolen and knitted fabrics. A winch dyeing machine is very suitable for this purpose. In this machine, a minimum of tension is exerted on the cloth being dyed. A dye winch consists of a power-driven elliptical reel A called winch mounted on a tank. It has a perforated partition B near the front which divides it into a small and a big compartment. The small compartment at the front of the machine is provided with perforated steam pipe, water inlet D and outlet arrangements. The addition of the dye and dyeing auxiliary is also made in this compartment from where they travel to the other through the perforated partition. A guide roller E is also provided for the movement of the cloth. In using winch, one end of the cloth F to be dyed is passed through the guide roller and over the winch. The ends are sewn to make a long continuous loop. The fabric is then run into the dye solution by the action of the rotating winch. During dyeing, the fabric is plated down the slanting side of the tank in the dye solution at the rear side of the machine until it is drawn out again by the winch. The movement of the cloth agitates the dye solution. The liquor ratio is much higher, hence water and heating costs are also high. Padding mangle. Dyeing on jigger or winch is a batch wise process. Only small lots can be dyed. For huge quantities, padding mangle is used. Material liquor ratio is lowest as there is saving in consumption of water, steam and chemicals. The basic padding operation consists of passing the fabric in open width through a small trough A consisting the dye solution B and then removing the excess solution by passing between positively driven squeeze rollers which constitute the padding mangle. A simple padding mangle consists of two squeezing bowls, the upper one of iron and covered with rubber, that is C, and the lower one of brass or ebonite, that is D, arranged over a shallow trough provided with two or more freely rotating guide rollers. The pressure on the bowl is obtained by compound lever and weights. The cloth enters the trough containing the dye solution. After passing through the dye solution, it is uniformly squeezed between the bowls and finally is batched, that is, it's wound on a roller and left for some time. The contact between the squeeze roller is known as nip of the mangle. Since the fabric dips in the trough and is then fed into the nip, it is known as one dip, one nip operation. In order to get consistent results, the liquor level in trough should be maintained by continuously feeding the liquor at the rate at which the fabric takes up the liquor. If the level drops, the further take-up decreases, resulting in gradual lightening of the final shade. This defect is known as tailing. Thus, the level of the liquor in the trough should be maintained till the last part of the fabric leaves the padding mangle. So, in the diagram, you can see a 2-ball padding mangle. In order to increase the penetration of the solution into the fabric, a 3-ball padding mangle with 2-dip, 2-nip operation is normally used instead of 2-ball padding mangle with 1-dip, 1-nip operation. In this case, the soft roller is placed between the two hard rollers. The pressure in this padding mangle is applied by hydraulic or pneumatic systems, which enable heavier and more uniform pressure and a more exact control to be obtained than by the lever and weight system. One advantage of the 3-ball padding mangle over the 2-ball machine is that it allows 2 immersions in the dye liquor and double squeeze, so that a better penetration of the dye liquor into the fabric is possible, particularly when azoic or VAT dyes are used. The next is high temperature beam dyeing machine. The hydrophobic synthetic fibers such as terylin necessitates dyeing at temperatures above 100 degrees centigrade. In this machine, high temperature and high pressure can be achieved. The machine consists of an autoclave C containing the fabric beam through which the dye liquor is circulated by a pump after it has passed through a heat exchanger E. The autoclave is completely filled with dye liquor, which flows through a cooler and is pumped back into the autoclave by means of injection pump F, and thereby increasing the pressure inside the autoclave. This machine is useful for dyeing knitted and woven fabric, which is wound on a perforated beam, and the dye liquor is circulated alternatively inwards and outwards while the beam is positioned horizontally or vertically within a closed vessel, that is the autoclave, capable of withstanding high pressure to secure high temperature dyeing. The width of the perforated part of the beam can be adjusted for fabrics of different widths. Above 100 degrees centigrade, the fibers swell to a great extent. The molecules of the fiber gain energy, move about vigorously, so that spaces between enlarge, and dye molecules which are also energetic enter these spaces and penetrates the fiber. The next is jet dyeing machine. It is unique in that it has no moving parts. The cloth in rope form A is introduced into a unidirectional liquid steam enclosed in a pipe. The liquor is pumped through a specially designed venture jet, imparting a driving force which moves the fabric in a totally enclosed tubular chamber. The two fabric ends are sewn together to form a continuous loop. It's becoming very popular for dyeing knit goods due to the absence of reel or drives. It avoids wear and tear on material and is suitable for delicate fabrics. Gaston County jet dyeing machine is a pressure withstanding cylindrical vessel with up to 6 separate tubular chambers arranged side by side, which are semicircular in shape, each containing one rope of fabric. The lifting roller B is covered with an elastomer so that the fabric will not be damaged. Let's look into the garment dyeing machine. So in that, the first is rotating drum machine. Silk hosiery is frequently dyed in a rotating drum type of machine, which consists of an inner perforated drum A with doors B. The drum is divided into 4 equally large compartments. These compartments are loaded and closed individually. The goods C are packed into the drum, the surface of which for silk stockings must be polished to the highest degree of smoothness, because even the least roughness or slightest scratch on the metal causes damaged goods through plucked threads. There is an outer case D forming a vessel in which the perforated drum rotates. A reversing mechanism causes the drum to make a certain number of rotations in one direction and an equal number in the other. The next is the toroid machine, which is also used for garment dyeing. A more recent development is this toroid machine for dyeing garments under pressurized conditions at temperature up to 140 degrees centigrade. This is especially used for dyeing garments containing polyester fibers. The pump circulates the dye liquor in at the bottom and it impinges upon the spreader plate A, which deflects the flow round the sides of the cylindrical outer vessel. It then flows over the top of the annular cage containing the goods, from which the pump withdraws the liquor through a central perforated pipe. A swirling action C is imparted to the dye bath, which keeps the goods in constant movement. Dyeing can be done in the form of fibers, yarn, fabric or garments. The most economical is to dye at the later stage in the manufacturing sequence. For special effects, however, it can be dyed at an earlier stage. There are various methods of dyeing. The selection of the method or equipment is based on factors such as dye, fabric characteristic, cost and the intended end use. Hope you have got familiar with the idea about the different methods of dyeing. Bye for now and meet you soon.